the next rule, which is rule 7. Now let's get to understand. Rule 7 says if two or more chains have equal lengths, this chain chosen as parent chain will be that which have the greatest number of side chains. Let's get to understand. If two or more chains have equal lengths, that is to say, when you take your counting and you're having different chains with equal lengths, the chain you should take as your parent chain will be the chain that has the greatest number of side chains. Let us get to now understand better what that rule is saying. So we kindly take up our rule 6 and let's look at our rule 7. So we have our rule 7 next, rule 7. And there we have the structure CH3, CH, CH, with a drop down CH3, and we have another CH2, CH3, we have CH with a drop down CH3, and then we have CH, another CH3, and last CH3. So this is what we have. Now looking at that compound, what is the parent chain? It is clear that the parent chain can be the straight chain. Now this is one counting. Let us look at another way we can get our parent chain. If we choose to go like this, now another student may choose to go this way, CH3. We want to get to understand what that rule is talking about. We have this, we have this, we have this, this, and this. Now, a student may choose to take his or her counting this way. You may choose to take your counting this way. You see, this is also giving us 6. And we may choose also, some other person may have his or her structure like this. Some other person may have his or her structure like this, CH3, CH, CH, CH3, and here we have CH3, CH3, CH2, CH3, and we have CH3. Now, another student may choose to take his parent chain to be this, that way, and we have this. So we can see that. Now, looking at these different numbering schemes, from the first structure, all this is the same compound. This is student A, student B, and student C. Now for student A, he has taken the straight chain as his parent chain, and he is having 1, 2, 3, 4 side chains. For student B, he has taken the bent shape, the table shape or the U shape as his parent chain, and he's having something like the iso compound as parent chain 1, side chain 2, side chain, and 3 side chains. Now look at student C. He has side chain 1, side chain 2, side chain 3, and side chain 4. So let's take a look at the rule. The rule says that when we have such kind of numbering schemes, that the chain we will take as our parent chain will be the one that has the greatest number of side chains. That is the rule. So for student A, B, C, who do we accept? Which of this numbering scheme should be accepted? For student A, there are 4 side chains, having considered the straight chain to be his parent chain. For student B, there are 3 side chains, as he chooses to go with the bent shape of parent chain. For student C, there are 4 side chains also, even though his parent chain is also bent, like the table shape of student B. So which of these numbering schemes should we accept? For student B is automatically disqualified because the side chains here are 3, and student A and C are having 4 side chains. So it means that for student B, the side chain, the numbering scheme or the pattern he took is wrong. For student A and C, who should be accepted? The fact is that student A and C are both correct in their numbering scheme. Whatever they are going to do, we give them the same name. But there is a rule that says when we have such kind of scenario, the straight chain should be considered the parent chain, and that is just what we're talking about. But what we want to establish here, as the rule says, is whenever we have this kind of scenario, the chain you should take is the chain that has the largest number of side chain. The chain that has more side chain, the greatest number of side chains, should be taken. So automatically student A and C are correct, but student B is wrong. Now between student A and C, we will accept the one of student A because the chain is the straight chain. Student A chooses to go with a straight chain, structure, and that makes things easier. That does not mean student C won't get the same thing. He will also get the same thing. But for simplicity, let us consider taking the straight chain. And to name that compound now, to name the compound, what will be a compound? Let us also consider which path should be followed. The path that should be followed is just like as we have seen in rule 6. And automatically the name of that compound will be 3-ethyl 2,4,5-trimethylhexane, just as we have seen. So this is the name of that compound, and you can see it also will give us the same thing for student C, because this will be our carbon 1, this will be carbon 2, this will be carbon 3, this is 4, this is 5, and this will be our carbon 6. So looking at that, this methyl, the first methyl here, this first methyl is at carbon 2. This is our ethyl. This second methyl is at carbon 4. And the last methyl is at carbon 5. So if we are to name the compound, it's still going to be 3-ethyl. Ethyl is at carbon 3, position 3. And the first methyl is at carbon 2, so it's going to be 2,4,5-trimethylhexane. The parent chain is 6 carbon atoms, hexane. So you can see it gives us the same name as what we have above. So students A and C are correct, but student B is wrong because he has only 3 side chains as compared to student A and C having 4 side chains. So that is rule 7. So let's take a look at rule 8. We're going to rule 8 next. Now for rule 8, the rule says that some important substituents, that is to say side chains or functional groups, some important substituents other than alkyl groups are halogens, which are fluorine, that is represented with F, and it is in this type of hydrocarbon nomenclature, it will be called fluoro. Chlorine also is there, which will be called chloro. Bromine also can come in, which will be called bromo. Iodine will be called iodo. Then we also have other functional groups like hydroxyl group, OH, nitro group, NO2. There could be double bonds. We can also have triple bonds, and even the amino group. So the rule says in some important substituents other than the alkyl groups are the halogens, the hydroxyl, nitro, double bonds, triple bonds, and amino group. In any chain where they occur, they are given preference. So wherever we have these functional groups or important substituents in a chain, they are given preference. And as we can see on the screen, the structure given to us there goes by the name 3-bromohexane. 3-bromohexane. And the other structure is 2-chloro-4-methylhexane. Now looking at the second structure which is 2-chloro-4-methylhexane, preference is given to chlorine compared to the methyl. That is to say, how? What do we mean by saying that preference is given to chlorine? Preference is given to chlorine because the numbering scheme started from where chlorine is, and this is it. Let's analyze that structure. We have CH3, CH2, CH, with a CH3 drop down, CH2, CH, CH3, Cl. So this is a compound. Now looking at the compound, where do we start numbering? Of course, we can see clearly that the parent chain is the straight chain. There is no argument over that. Where do we start numbering? Left or right? Some students will start numbering from the left-hand side. When you start numbering, carbon 1, carbon 2, 3, 4, 5, and 6. If another student starts numbering from the right-hand side, this will be 1, 2, 3, 4, 5, and 6. So, where do we start numbering? Now, look at the name. The name is 2-chloro. So, it tells us that the numbering scheme started from the right-hand side because chlorine is now giving a preference compared to methyl. Chlorine is giving preference compared to methyl as a functional group. So, it tells us that that honor given to chlorine made the numbering scheme to begin from the right-hand side. So chlorine falls under carbon 2 if we are to start from the right. And that is why the name is 2-chloro-4-methylhexane. That is the name of that compound, 2-chloro-4-methylhexane. So looking at the rule, it says that in any chain, there are important substituents that may be present. Fluoro, chloro, bromo, iodo, or hydroxyl. Even nitro groups also may be present. Triple and double bonds may be present. When these species are present in a hydrocarbon chain, they are given preference compared to alkyl groups. That is compared to methyl or ethyl. They are given preference. So let us take a look at more examples. We have now seen all 8 rules governing IUPAC nomenclature. So now we are going to take a look at more examples and learn how to give these structures. Now, in case dear students, you are still not so clear about IUPAC nomenclature, I believe what we are going to do now will help you in a very long run to understand better. So I would like us to follow the class now as we proceed. So we're going to be taking a look at some more compounds. Let us get to understand what we have just done.